Hello, welcome to ISAT330 Sustainable Manufacturing Systems. This is Lecture 10, Cost Modeling and Lean Manufacturing. All right, first we're going to look at manufacturing cost modeling. So in cost modeling, mainly want to discuss what is the cost structure, and I also want to go through some of the basic cost modeling methods like activity-based costing, process-based costing, job order costing, and life cycle costing. All right, so some of the terms about the cost in manufacturing, when we are modeling costs, that are actually all different kind of costs. For example, one kind of cost is a fixed cost. So fixed costs are those costs that are not variant with respect to changes in output and will occur even if no output were produced. So what it means is that, for example, if you purchase the plant and equipment, it's your rent, and also property tax or salaries, regardless. So regardless if you produce products or not, you have to pay them, right? Or regardless how many products you make, you have to pay that. For example, you rent a place for your factory. If you make 10 products a day, you still have to pay the same rent, right? If you produce 1,000 products a day, you still have to pay the same rent. So that is a fixed cost. It's not changeable with respect to how many products you make. Okay. Well, another type of the cost will be the variable cost. So variable cost will be depending on the number of output or the level of the output, like the materials, right? The more products you make, the more material you will need, right? So that's variable costs. So when you are doing cost modeling, then you have to look at if those costs are actually depend on the number of products or parts you make. For example, in the machining process, well, the more time the more products you have to make, the more time you have to operate the machine, right? So that will be the cost that is related to variable cost, right? But the machine itself is a fixed cost. For example, you spend $1 million to purchase this machine, and in the next 10 years, you rarely use it, right? So that's a fixed cost regardless how many products you make with this machine, right? If your plan is to keep this machine for 10 years, if you never use it, you still have to pay this $1 million. If you use it and then you produce 1 million products a year, you still have the same cost of the machine, right? So that's how it works with the variable cost and also fixed costs, right? Another one is the direct costs and the indirect costs. So direct costs are costs that you can easily see, right? And also you can easily trace them. For example, the material cost, right? That's a part, that's a material that's in the product. You can see it, right? Like your phone, right? There's a screen, right? There's electronics in it. You can see it. And also same, the labor, what is the labor cost in it, right? But they are really easy to see these costs. We call it direct cost. But there are a lot of actual costs that is not direct cost. We call it indirect cost. So indirect will be, for example, when you are making this product, there are actually a lot of energy getting involved in it, a lot of transportation, a lot of movement. So on the shop floor, all these activities are not actually counted as direct costs. It's not easy to see it, but these are the costs actually embedded in the operation. And when the company actually selling this phone, they actually counted those costs in it, right? If the company are doing very poorly on the cost modeling, and they do not see those indirect costs, Well, the problem is that if they only use their direct cost to price their product, they may lose their profit, right? But if they see this indirect cost, they have a better idea of how much money they actually put in production and what is the profit margin of the product. So that's why cost modeling is very important in production companies, especially in management, because you need to know where do you spend your money and how much you spend on what activities in production activities. All right, so these are costs, all these costs. Then next, let's look at different methods for cost modeling. So first one is the process-based costing. So process-based costing means you analyze the net cost of the manufacturing process. For example, filling the soda over a period of time. Then the unit for filling the cotton is simply the net cost incurred while filling all the bottles during the period divided by the number of bottles filled, right? So this is process-based. Also, when you are looking at the process, you probably want to check. Okay, this is the process, and what are the materials, right? Those are materials. Maybe this is the energy, and also what other information. Maybe this is the information handling, or different activities that are involved in this process. Then you have this output. So you know what are these costs around this process. Everything is based on the process. So this is a process-based modeling. Another one method is job order costing. So job order costing, it is to help track all the costs that on an individual product's basis, right? So that's based on the job order. So you need to check all the follow all the costs related to that job. And activity-based costing will be it will be the cost associated with a single manufacturing task, right? For example, if it is a milling, or is the bending, or it is a transportation, or some other activities, and you get to see what is the labor cost, what are materials, what are the equipment, what about the energy, everything that involved in achieving the purpose of that activity should be counted as costs. Okay, and the last one is the life cycle costing. So life cycle costing mainly is dealing with the product or equipment or a certain project. The life cycle. You take into account the entire life of the project or equipment or product and calculate what are the costs. In life cycle costing, a lot of times we have to use engineering economics that we learned in the past in calculating what is the cost over the life cycle, because for equipment it can be 10 years, it can be 5 or 10 years, or even longer, right? For a project maybe there's a lot of years. So that's why the interest rate will be and time value of the money will play an important role in life cycle costing. But make sure to account all the cost items along the life cycle, right? All right, for the cost structure, in one manufacturing company, I usually categorize them into 3 different levels. First level is operation level. So in the operation level, what happens is that so basically this is one single unit process. So one single unit process means if it is a milling process, then you probably just some of the milling centers, or one CNC machine, or one mill machine, there, and with 1 or 2 operators operate that machine for one process. This is the one process, right? And when you look at the operation level, they are composed of a lot of processes. There are many processes, but at operation level, I only look at one single process information. All right, so for one single processing information, what happens is there will be several different cost items, like the energy, the tools, equipment maintenance, and also labor. So these are the typical ones. Right? Sometimes you might also want to count some information handling or some other items. Depends on what's really happening, at that specific operation, at that specific process. All right, then what about shop floor level? Now we need to look at what is really happening at the shop floor level. So at the shop floor level, there are also a lot of costs that we easily see, like electricity, right? So electricity, for example, the lights, right? The lights need to be on, the heatings, right, in the winter, or the ventilation, and all different facilities will need electricity and also the gas, right? These are some of the costs that happen at the shop floor, not specifically at the operation level. Well, at the operation level, if it's a single machine, you can easily calculate how much energy is actually used with that machine for certain process for processing products. Well, at the shop floor level, mainly those kind of facilities serve the whole shop floor, not just one single process. Okay. All right, so there are also some other materials like ancillary materials and equipment like computers, and some other like safety and health facilities or equipment or devices all happen on the shop floor because they are not serving for one single process. They are serving the whole shop floor. Same with scheduling, right? You need to have labor, engineers, managers. They're all working on the shop floor to make sure that the production activities can happen smoothly. Okay, and move smoothly. Well, there's another level which is higher level than the shop floor, that is the enterprise level. So at enterprise level, mainly the activities happen at this level are administrative or marketing or strategic or policy making, those kind of activities. For example, selling, marketing, the administration, R&D, and also some of the costs related to include the cost of goods sold, right? The tax, the energy consumption that is not related to production itself, but also the energy used for service or administration purposes. For example, the printers, right? The computers, and the lights, and heating, all the other things that require electricity. They are the energy cost. Well, we have the three levels. I need to let you know that they are not separate. They are not separate. So all the processes, right? All the process models, they're gonna aggregate and into the shop floor level, right? Shop floor level. And then here, the shop floor level, you will aggregate and into the enterprise level. So usually, what happens is that the shop floor level cost will be the manufacturing cost. How much it costs for manufacturing products or for production, right? So this is and also operation level cost will actually aggregate and into the shop floor, into this probably process operations cost, right? So all of those will aggregate into this, along with other cost items. So that this is not separate, but instead they are they're always in each other. I kind of discussed a little bit about this operation level. What are the cost assessments? We look at the tools. If you have a machine, then we'll look at the machine tool. How long it take it can be used. If there's a lot of tool wear and you need to replace the tool, then how much money you lose, how much money you have to spend to get a new tool. And same with the materials, right? So the material for the product itself, that is the material, and also there are a lot of ancillary materials that to assist the production. You also need to account those kind of materials in operation level cost assessment. For the equipment, if it is one single machine or maybe some machine in the work center, then you need to calculate what is the principal, how many years they're using it, the interest rate, and how much money you can get after you salvage it. What is the salvage value of it? So that's the operation level cost assessment. And also when you're doing the cost modeling, your cost assessment, you want to make sure what is the unit for that, right? Should it be your dollar per unit, or dollar per a certain period of time? But usually, the unit we use is dollar per unit. Another thing we want to talk about is if it is equipment, right? You can, for example, you can operate the equipment for 10 years. How do you get this dollar per unit? In this case, you probably want to see, you want to find out what is the cost for the equipment, what is the annual cost, and also how many products, how many units can you produce over the year, right? And also how many units can you produce over a month, over a day. In this case, you can calculate, okay, what is the equipment cost when we are producing how many products. So that's why you can see, okay, suppose equipment is $1 million. $1 million. That's why that's divided by the number of units, right? So you get what? Get dollar per unit for the equipment. You can see if you make more products, the cheaper of this is the equipment cost, right? If you make fewer products, means the equipment cost is actually gonna go up. So that's why it's a fixed cost for equipment. Labor the same. Most time they are paid by salary, so you have to pay them regardless how many parts they make. Sometimes there can be fines. Sometimes there are compensations. For example, if you make more products or you do some extra work, then you can pay more, and your extra work should be accounted by how much extra work, how many extra products or parts you make during the day or during a certain period of time, right? So in this case, that will be the variable cost, right? Depending on how many you make. But if you're gonna be paid by the salary only without a compensation or without any extra payment, then the more product you make by the certain labor, actually the cheaper that cost. Well, at the shop floor level cost assessment, I discussed about this. And enterprise level RD, different cost items. All right, now let's look at one case study. So the case study is the one I was working in Oregon with a company that they are making incubators or fridges or some other laboratory equipment. And I built a cost model for them during my PhD study. So basically, I analyzed almost everything there and studied for the company, the whole company for 2 years. And then I did a lot of projects, and one project is to build a cost model, because cost model is the first thing we want to see before we're doing the improvement, because we want to know where the company actually spending the money on their production, right? So that's why the cost model is important in production management. And this is a little bit background about the company. They have the punch process, the brake, the bending process, the welding, the painting, the assembly, then pre-assembly, and then assembly, quality assurance, and packaging and shipping. So that's they separate into two shops. One is a metal shop, the other one is assembly shop. So when you are building a cost model, the one thing is usually the cost model are in the Word Excel file that you have to define a lot of variables, because if you only input if you only input a number, it's hard to be changed, because it's hard to analyze, the cost model, because if you change one, you also have to change a bunch of other consequent variables or the values. Right? It's hard to track. But if you define variables, actually it's a lot easier, because variables, these are the variables, and you can assign value on it. Right? If you change one value of the variable, you only change the value, but it's not change the variables. So that's why in a cost modeling, it's better to define all these variables to make sure you are in a good system of cost modeling. So I actually define a bunch of the variables for each of the process, and then did some calculations. So this is the result for the operation level analysis result. So mainly I was looking at the energy cost, labor cost, and also materials, tool machines, right? So these are of course, because I have for example, this punch process, right? I have to know how much energy is used by the machine. So what I did was I hook up some energy loggers on the machine at the power unit, and then when it's machining, I record what is the power. When it's non-machining or when it's standby, what is the power when it's off, right? Also, you can compare the power difference with different situations. Another thing is you need to know the time, how long it is working, how long it is processing the part, how long it is standing by, and how long it's off. So based on all this information, you can calculate the energy cost as well as the labor cost, right? So labor cost is, in this case, it is mostly based on the hourly wage of the labor, and it really depends on how long the labor is or an employee is processing the parts. If they are working or doing operations, means they are they can get the full wage on that. But if there are a lot of waiting times, what happens is that you're actually wasting your labor, right? Wasting those kind of money. So it's not modeled here. And you want to understand why is that. Same with bending, welding, painting, and assembly, and all these other processes. You analyze different things, and then trying to find out, what is percentage of the cost actually for each of the process. And then probably can find out some of the bottleneck or the weaknesses and seek improvements. All right, for the shop floor level cost, same. You also need to define what are all these variables related to different cost items, and make sure you have a good definition. And after you build a big, Excel file or this big cost model, and you can generate some results from an analysis. From here, you can see the raw material cost actually costs a lot, right? And then the next one, you can see is the actual labor cost. So basically, material cost and the labor cost are the main cost items in traditional manufacturing systems. It's not always like this, because it really depends on what kind of company it is, right? For example, if it is really high tech and you only have one process and the equipment is like $10 million, right? In this case, probably the equipment cost will be higher, right? So that's why it really depends on the industry and also the nature of the company. Enterprise level, the cost, same way you define the variables and then aggregate all these manufacturing costs in it. So because when you are making decisions, you have to look at all the different kind of costs, compare with manufacturing costs, and then trying to figure out what decision you can make. So here you can see the manufacturing cost and all the R&D cost and administration, marketing, and the cost of goods and the selling cost. So from here you can see, okay, actually the manufacturing cost cost a lot, and then administrative expenses here, and then maybe probably that following then it's with the marketing expenses and the R&D, cost of goods and the R&D. You might say, okay, maybe I need to spend more on R&D. Or maybe my manufacturing cost is too high, right? So that's this is how the cost modeling can help you understand your company, and then based on the result of cost models, you can actually find what need to be improved in your production systems. All right, so now let's come to the next topic, which is the lean manufacturing. So lean manufacturing is a very important concept in production companies, because actually it's not just in production company. In a lot of service industries, it's the same thing. There's a philosophy, it's called lean philosophy or lean thinking, that you have to think and always thinking with lean principles, and it may probably gonna help you improve the efficiency. What are the lean principles? So I really encourage you to watch the videos, so you can see the blue test, and you can click the test and click the link, and you can it will direct you to the videos. So basically, the lean principles are the value stream, flow, pool, and perfection. So value means what the customer would like to pay for, right? That is the value. The value does not mean that what you do, instead of what you do for the customers, and that the customer would like to pay for it. Right? For example, if you got this phone, and then the customer would like to pay for the materials, would like to pay for the labor, would like to pay for maybe the equipment that you need to make it, right? So these are the reasonable costs or the values that are needed to produce this phone. But the customer would not like to pay for the holding cost of the materials. Right? You hold a lot of inventory, right? You spend a lot of money on managing the inventory. The customer do not want to pay for that, because that's not a necessary value that is to produce that kind of phone. You can definitely reduce that, right? So that's the value. You have to define what is the really value to the customer's needs. Then the value stream will be a stream of activities that create the value, right? Mostly it's the company operations. And the flow means makes the parts run, right? Like I discussed in the first class, you don't want all the parts sitting on the shop floor without moving for a long time, because you are occupying a lot of space, you lose opportunities, and you probably have to spend money to hold that inventory as well. So that's why flow always have the parts run on the shop floor. It will increase your efficiency. Pool means you produce only what is needed, right? So I think decades ago, or maybe half a century ago, what happened in the past is that we produce based on how much material do we have, right? We just keep making parts. And then get more material, keep making parts, but we people do not care that much what is the demand. If we're over making a lot of products, but there are not a lot of demand, what happens is you got too much inventory, and you put cash to the physical products that you cannot sell, right? It's very dangerous for industry like that. Okay, so that's why you only want to make what is needed, right? Based on the orders from the customers. So that's a pull system instead of push system, right? If you got materials and you produce based on how much material you have, that's the push system. But push system is only produce what is needed. Well, the last one is perfection. So perfection means make lean thinking and continuous improvement a corporate culture. Right? It's not only one engineer or one manager is doing it. Right? It should be the whole company's culture. So every time you got a problem or see a situation and you think lean and think how can I keep improving it, and what are the really values in this activity, in this project, right? And how much then to determine how much time you want to put in it. And if there are some of the non-value added activities, then you probably want to get rid of them, right? So that's a perfection. It's a continuous improvement process. All right, a key word, a very important word in lean is the waste, right? So if you want to know the value added activities, then we'll also need to find out what are non-value added activities. So non-value value added activities are actually the wastes, right? So in the Japanese word, it's called muda, right? Muda. You need to remember this word well, because it's probably gonna happen a lot in production companies in industry, because muda is a Japanese word for waste, and people sometimes just use muda instead of waste. You need to understand what it means. And there are 7 types of typical wastes, and also 1 type of the it's called utilized people waste that people also talk a lot. So the 7 types of waste. The first waste, same. I encourage you to watch the video. So you need to click this video and then try to understand what are how they explain the 7 types of waste. So the first way is the waste overproduction. Like I said before, you do not want to produce too much, right? And you only want to produce what is needed, right? We only want to produce what is needed. So that's waste of overproduction. Have a pull system will do that. The waste of waiting, it's more like when we're doing the cycle time analysis, the imbalancing of the processes will result into some of the waitings, right? So you might want to eliminate those kind of waitings or reduce those waitings because they are non-value added activities, right? Another type is the waste of transportation. So waste of transportation means if after one process you have to travel a long distance to another shop or to another building, and then come back again, and then come back to another building. So this is a waste of transportation. You do not want those designed like that way. And a waste of over processing means if you can process or make the product in a very simple way, you do not need to design hundreds of steps to make it, right? So that's the waste over processing. And the waste of inventory means you do not want to hold a lot of inventories, right? If you hold a lot of inventories, they are waste. Waste of movement means from the operation unit operation perspective, you do not want to move too much. Like when you are doing the one, say you're operating the machine and you put the machine really far from the where you put the materials. Well, in this case, you probably have to have the operator to move a lot, and that going to cause some issues. And waste from product defect, because defect is non-value added, right? And then in fact they actually decrease the value. So get rid of the defect or reduce the defect by identifying where are these wastes. And the last one is unutilized people, right? Unutilized people. So like when we're talking about in the cost modeling, you have to pay with them, and if the people are not utilized, right? They do not have any work to do. They just sit there doing nothing. Then that's not well used, right? So that's you end up paying more, and so that's also the type of waste. All right. So after we talk about waste, there are another 2 Japanese terms probably gonna also use a lot in production. It's a mura and a muri. So mura means it's unevenness in productivity and quality, right? And muri means the overburden of the machines, managers, and production associates. So it's the mura and the muri. Also, the most important word is muda. You need to understand all the different types of waste, and also you need to know what it means by mura and muri. All right. Now let's look at the waste reduction. How do you do lean, right? How do you practice lean? And there are a bunch of the methods, so we're gonna talk about it one by one. And first one is the 5S. So 5S means there are five principles or 5 activities you need to do in order to organize or make one your workspace more organized, right, or more efficient. So 5S are sort, setting order, shine, standardize, and sustain. So sort means you only keep the stuff you need or the item you need in your workspace. If there are something that you never use or rarely use, you probably want to put it in the faraway place or remove it at all, right? And the second one is just sort means sort out what are the important, what are not important, and only keep the very important one. You use something you use in the workspace. And setting order means you can easily find where it is, right? For example, you bought a toolbox, right? You can see the toolbox. Usually they have some different places you can put your tools, right? You can easily find that space because they designed that way. So this is setting order. Also, for example, the scales, not the scales, the screwdrivers, that dimensions. You got small screwdriver, bigger square screwdriver, and how do you easily find the right one? Because you put in all these screwdrivers in a sequence, right? Setting the order from small to large. Then you can easily access to that. Next one is shine. Always make your tools, your workspace and equipment is really clean, right? Without any defects. So that's called shine. No one wants to work in a place that is really mess, right? A lot of messed up and stuff here and there. It's dirty, and you can't find anything, easily find anything, right? The next one is standardize. So standardize means you set up a normal what is the normal situation, what is abnormal situation or condition. Because once you have this kind of standards, when there's something happened, you know that it's off the standard and something happened and you have to fix it, right? So this is standardized things. And last one is sustain. So after you did all the stores, setting order, shine, standardizing, and then you have to think about how to sustain your behavior, right? Yeah, you clean everything, did very well today, but tomorrow is back to a mess again. You don't want to do that. So that's why you need to sustain, set up a good culture, determine who's going to be responsible for what activities in order to sustain it, right? So that's 5S. So the link actually is able to take you to a video of an example how some medical workers actually use 5S to reorganize, right? To reorganize a room with a bunch of supplies. I think it's a really good example. In this lecture, you have to watch a lot of videos. Because it's not something like I say it and you understand or you can do it. You have to see how other people do it and you practice by yourself. Then you understand how valuable it is. Right? So 5S is the one tool. Another tool is the value stream mapping. We talk about the value-added activities, right? What are the values? Then you want to look at, okay, what are the activities actually creating values? So that's the value stream mapping. So you map out all the activities on the shop floor or of the whole company, and then find out what are the value added, or what are the non-value added activities. There's a standardized way to draw a value stream map or VSM. So because all these symbols are standardized, you cannot create your own, or you should not create your own symbols, right? You have to follow all the standards. Now, what is the basic setup of this value stream mapping is It's from left to right. From left, so left is the suppliers, and right is the customers, and also it's composed of a bunch of the processes. So you can see each box is one process, right? And the green arrows here are the you can see here are the transportation, right? And this triangle means inventory, right? Work in process or inventory in between. And then you can see the machine. A next process will be drilling process, then will be cleaning, inspection, and packaging. Right, so these are processes on the shop floor. Then in each box, also there are some of the informations, right? So the information will be the one, you can see there's the one labor, and then CT means cycle time. Right, you need to label or write what are the key information here, right? Uptime or downtime. So here you can see it takes about 45 minutes. So the bottom here, that's the axis of time. That's the axis of time. But you can see there's some of the lower, some of the higher. The lower ones are the waiting times, right? That's not processing, not being processed by the machine, by the process. Right, so that's why you can see the 5 days, and then only 45 seconds, and then you wait for another 10 days. Right, so the lower ones are non-value added activities, and the higher ones are value added activities. So you need to know what's the time, right, on lower ones and higher ones. All right, so after we look at the bottom, then let's look at, okay, from the supplier to the first machine. You can see there's a truck. So truck means they are transporting or getting the supplies from the suppliers. And how much supplies we have, right? So or how often do we get supplies? This is information you need to put it on the truck. Is it weekly, or is it daily, or is this monthly? Right? You need to write it down clearly. And same here is there's put a little bit of inventory at the triangle here to the first process. And so for the supplier, the truck, you also need to label that what is the lead time, right? What is the cycle time, and what's for that. And same with shipping. Shipping, you also need to label some of the basic information about that, and then to the customers. And another set of another part of the VSM is in the middle part. You can see the production supervisor, production control. So there are two different kind of lines. One is the straight lines. You can see those kind of blue straight lines, and also those kind of flash lines, right? These are the flash lines. So straight line means there are manual information, right? Your information are manually handled. Right? For example, here maybe the supervisor gonna manually talk to or give the each of the process operators a document or explain the information, right? So how it works. So you can see here the production supervisor actually discusses or communicates with each of the process on a daily basis. Well, above the production supervisor is actual production control manager. And A gonna talk to the production supervisor every week, right? So it's a weekly, and then also it's a straight line, so it means that's a manual handling information. And if it is in computers or by phone or by saying something else, then that's the flash lines communications. And also there are communications of monthly, weekly orders, all these information. So basically, this is the whole setup of this value stream map. You need to include all the items in there, right? And based on the system or based on the project, based on the processes you are trying to analyze. And you can see all these symbols. Make sure you use those standardized symbols. For some of the tools, they probably have those symbols already embedded in the software, but sometimes they might not have that. For example, Visio or some other engineering drawing tools might have this in the VSM, but not all the software have that. And this is the one example you can see you can see different label symbols and also information in it. Pay attention to these blast one circles. So these are, we call it Kaizen event. Right, don't have that. It's called Kaizen event. So Kaizen burst means these are the places that need to be improved, or that's the bottleneck, or that's a problem, right? So you can see in this map where the problems are, right? Kaizen event. How do we do it, right? So that's why from the value stream map, you can easily identify what are the value-added activities and what are the non-value-added activities and where are the places that you need to work on, right? So that's how the value stream mapping actually going to help the continuous improvement. And this is the one map I did for the company cost modeling. So we composed this map in probably we spent a week time in the company and trying to track all these orders and then figure out the time, and then eventually I draw this value stream map. So just give you an example how it's used in practice. All right, when we're talking about lean, I have to talk about some of the pull system, because pull system is really just in time, means may only make what is needed, but it's not always that you have to all the production activity has to be pull only. Why? Because if you only have this pull system, means actually what happens is that you might gonna lose or how have some delays in fulfilling customers' orders, right? So that's why sometimes we also have this leveling. So leveling means we smooth the production need with a certain amount of inventory. We're still gonna keep a little inventory just to make sure that there's no waitings, there's no shortage of materials that cause delays, right? Cause of the waitings, cause of we cannot produce because I don't have materials, right? So that's the leveling. It's still gonna keep a little bit shorter inventory. That's leveling. So a mix of leveling and the pool means we have, it's called a level pool system. It's a mix of pool and level. Then that make it a better system that will be efficient because it's using the pool system to drag the production, but also it has a little bit level. Means that if there are some situation happens, the system is resilient enough to deal with the situations. Right? Well, the most ideal case is a one-piece flow, which means no parts actually is sitting on the shop floor. Everything we are doing the one piece. But that is very ideal. And most time when we are talking about one piece flow, we're actually talking about reduce the batch production. We do not want to have a really large size of the batch, because with the large size of the batch, what happens is they're gonna create waiting times, right? Create WIP. That's not desired. But that does not mean that you're gonna reduce all the batch to one part. It's not feasible, and a lot of times having a certain reasonable size of the batch actually is gonna help reduce the cycle time. Why? Because if you reduce the batch and you have to constantly change your setups, means that the time for changing the setup or repositioning time is actually gonna go up, right? For example, the pinning process. All right. If I can group them or have a batch of the same color, then I can just use the same kind of paint, and save time. But if I do not batch them and I only paint one green and then one red and then green again and then one red again and then blue, in this case, you have to, every time you put the new part, you have to change the color, right? You have to change the color, and then that's actual activities. That's actual time you have to spend just to change the setups. So that's why having a short sum of the batch size probably will make more sense but it really depends on the nature of the system, production system you are at, right? So all these tools are not dead, right? You have to use it exactly the same way it is. Instead, you can be creative and then figure out what are the conditions that you can use those tools. All right, another a very useful method is the Kanban system. So Kanban system is based on a pull system, right? So what happens is that you have different processes, process 1, process 2, process 3, and process 4. And so process 3's production or process activities is triggered by what? It's triggered by 4. It's triggered by 4. So how does 3 know that it needs to make more? Because that this information is from 4. But how it works? It works with is a Kanban. So Kanban means it's a Japanese word for visual signal and card. I think the character is called Kanban, right? Something you can see that you need to produce. Why? Because the Kanban card can be a card. So basically, it shows what? It shows it's a small inventory level, right? At each of the process, I'm gonna build a very small inventory, and it has a reasonable size of inventory in order to buffer, the or smooth the processes. And all right, so if we're gonna set a inventory level of this is the inventory level, and this is the inventory level, the full inventory level of the when it's short inventory. All right, so what happens is if there's some customer needs here, right? If the customer needs, it will tell 4, right? If it tell 4, say, hey, I need 10 units today, 10 products units today, and then 4 maybe only have 2 units, right? 4 maybe only have 2 units. Say you have 2 units. And what happens is after 2 units is used, it's running low. It means 4 need more. 4 need more products. 4 need another 8 units. And then this information will pass it to 3. Because if 4 needs to produce 8 units today, and then it will need 8 units from 3 of the what is the final parts from out of 3. But 3 in this case, probably 3 only have 3 units, but it need 8, means it's short of 5. It's short of 5 here. So that's why the 4 will pass this information says that to show it on the Kanban card that 3 will need to make another 5, right? Because because you see, 4 has took that 3. 4 has taken that 3, and then the Kanban level is going down. The Kanban level is going down, and then 3 knows, okay, I need to make more in order to fill this Kanban to this level. Because right now, the level is going down. So I need to fill this level. So this is how the 3 knows that it will start to make more parts and how many parts it will make. So basically, the information is transferred or handled by the Kanban. So 4 does not have to immediately talk to 3. Basically, all they need is just to change the information on the Kanban, right? So, and this is the Kanban example. So Kanban example, it shows what the part number, the description of it, and also the order quantity, right? What is the current order quantity of it? If 3 sees, the quantity is actually got really low, in this case, okay, the 3 will start to make more parts, right? So this is a Kanban. Sometimes the Kanban can be like this. A lot of times it's quantity that really matters a lot, right? And I encourage you, or not actually encourage you, have to actually look at all these videos, watch those videos to have a better understanding of how the Kanban works in the real case company. Well, another method is called jidoka. So jidoka, there are a lot of Japanese words, right? Jidoka is aims to prevent the defective products, right? Or if any process have defects, then the jidoka means it will respond really fast, and then to eliminate overproduction by what? By focus on understanding what really happens at that time, right? So for example, you have a production line, and then at one process something happened. Then immediately there's a signal from the send it to the supervisor or send it to the manager, who will be fastly respond to this situation and analyze what's happened. Because if you keep this production line moving, what happens is that you will probably gonna pass the defective parts to the next process. So usually a product gonna stop the whole line and then just try to figure out the problem, but not always, right? It really depends on the situation. If it does not affect the next process, then it's fine. But if the parts from one process gonna affect the rest of the process, then you probably have to stop all these processes to trying to fix the problem first. Because remember, it's the quality cost. So if you produce defective parts, that's the cost. You should watch this video again. Watch this video and then look at how judoka actually practice on the shop floor. All right, next one is total productive maintenance. So this is the more related to the machines, right? So it says that you have to constantly do some maintenance of the machines in order to avoid any situation happens. Because if those kind of breakdown happens, then gonna cost you much more than if you do some preventive maintenance, that you can avoid those issues, right? So that's the total productive maintenance, and it will tell you what's the make a policy when to do the maintenance, and how much breakdown you can avoid, and also all these different kind of activities related to it. Watch this video and have an idea how this practice in the companies. Well, lastly, I want to talk about continuous improvement and also about Deming. So when we started to learn manufacturing or production, you probably heard about this person, Deming. So Deming is a very well-known, famous American expert or philosopher on production. And he used the statistical analysis in quality control in manufacturing companies, and wrote a lot of nice books. And his famous one famous tool is called a PDCA. So it's Plan Do Check Act. So Plan Do Check Act means it's a cycle, and you always plan first. Look at what are the resources, criteria, limits, and then do it. Collect data, observe, then check. If things are doing well according to the plan, and then act and how to improve next time. So then do this cycle again. So this is a continuous improvement tool developed by Deming. Well, Deming also has a lot of lectures in management. So I encourage you to watch this video and then trying to look at how you talk about management. And the Deming's 14 points are very useful, and I'll say those kind of principles or some items you need to pay attention to when you are doing production management, or you are working as an engineer or continuous improvement. And these 14 points are all related to continuous improvement. For example, CC dependence inspection to achieve quality. Some of the quality experts say that inspection or quality assurance is not needed, right? Quality assurance is needed if you have really high quality processes, right? When we're talking about quality, we did a lot of process capability those, right? So if your processes are high quality, means it will not fail or fail at really tiny probability, and we will make good parts. And if all the processes are like this, eventually you will have a good good product, right? You will have a really low failure rate on the final product. So that's why certain inspections or quality insurance are actually not needed if you have really high reliable line or production processes. And a lot of other a lot of other principles I think are also important, like break down barriers between staff areas, and these are psychological issues. You might want to have more communications between staff so that they can what happens, or if a problem happens, they can easily communicate, and also going to help the psychological problems. So read through all these Fleming's 14 points and also listen to the video. Hopefully you can get a better idea about lean manufacturing. In fact, in this course, we only give this one short lecture, right? It's not even a whole lecture. Just give you an introduction about lean manufacturing. We have a course about lean, or it's called Six Sigma continuous improvement, and so at our concentration level. So if you're on concentration, there's the entire course about Lean and Six Sigma, and it's gonna be a lot of details, a lot of hands-on experiences, and also if you're looking for a job and in the area of production manager or continuous improvement or industrial engineer. And so there's a exam, it's called a Six Sigma exam. So you can there's a green belt, I think yellow belt, green belt, and black belt. And if you get a green belt, or if you get some belt after you graduation, then you probably at a better position of looking for a job in Lean. And again, so Lean and Six Sigma is not just in manufacturing, although they started in manufacturing. They can be applied in a lot of other places, like in hospitals, in banks, in service industry, in government, in a lot in tourist sites, like for example Disney and a lot of other airports. They all can be applied in those different industries. All right, so that's pretty much all for today. And some takeaways: you know what is cost modeling and different types of costs. You need to understand what they are, and also 3 different types of cost modeling methods, right? The process-based costing, activity-based costing, lifecycle costing, I think job order costing as well. Structure of the cost in the manufacturing system. You know how to build a cost model for a company. And lean manufacturing, the same. You need to understand what are the lean principles, the key terms you need to understand, right? The 8-7 types of waste, how to do waste reduction, right? The different tools, 5S, VSM, what is a pull system, the level pull system, and also TPM, Poke-Yoke, continuous movement, PDCA, and 14 principles, or 14 that means 14 points. So go through all these terms and understand what it means, and they should be very helpful in your future career. All right, that's all for today.